You're running for your life, legs pumping, adrenaline spiking, but you're barely moving. Everything feels heavy, thick, like running through water. Your legs won't obey. And then you try to scream, and nothing comes out. Welcome to dream physics.
That slow-motion torture isn't a glitch in your dream, and your brain isn't weak. Your brain is actively paralyzing you on purpose, and understanding why unlocks the weirdest physics your body lives inside every night.
Slow-motion dreams and dreams about falling are among the most commonly reported dream experiences. Nearly everyone has had one, and they feel incredibly real. Your legs are heavy, your punches are weak, gravity is wrong.
The second type, the falling dream, often strikes right as you're drifting off to sleep. You feel like you're plummeting, your body lurches, and suddenly you're awake, heart pounding. During REM sleep, when most vivid dreams happen, your brain actively paralyzes your voluntary muscles. It's not that you're weak, it's that circuits in your brainstem are releasing chemicals called glycine and GABA that hyperpolarize your spinal motor neurons. Your muscles receive the message, stay offline.
So while your motor cortex is actively generating movement plans, you're running in your mind. The execution layer is blocked. Your brain still tries to run. It just can't actually move.
The result is effortful, sluggish movement. Researchers have measured this precisely. Motor tasks in lucid dreams take 40 to 50% longer than the same tasks performed awake. Counting takes the same time, but physical actions are significantly slower.
Here's the key insight. Your brain isn't suffering from a time disorder. Your sense of time stays normal. It's your simulation of movement that's slow. Because your brain is trying to predict the sensory consequences of action without any actual feedback from your muscles. It's guessing what moving would feel like, and guessing takes longer than doing.
The falling dream works the same way through a different door, the vestibular system. As your muscles relax at sleep onset, your inner ear is still trying to track your balance. The sudden relaxation gets misread as actual falling, and your brainstem fires a protective reflex to catch you.
This is why lucid dreaming, becoming aware that you're dreaming, activates specific regions of your brain that normally stay quiet. The anterior prefrontal cortex, the parietal and temporoparietal cortices light up. These are the regions that track self-awareness and metacognition.
When you lucid dream, you can leverage that self-awareness. You recognize the slowness as a sign that you're dreaming, and that recognition alone changes how the dream unfolds. Some lucid dreamers even use the knowledge that motor tasks are slow to actively practice skills. Athletes have trained tennis serves and coin tosses in lucid dreams and seen real-world improvements.
The strangest insight here is that the slow motion feeling isn't about your brain being tired. It's about your brain protecting you. By paralyzing you during REM, your brain is preventing you from acting out your dreams, from throwing actual punches or sleepwalking off a balcony while your unconscious mind is running away.
Understanding that the paralysis is normal and protective can actually ease sleep anxiety. Falling dreams and slow-motion dreams aren't warnings. They're not signs of illness. They're the expected, predictable output of how your sleep neurobiology is designed.
Every time you can't run fast or punch hard in a dream, every falling sensation that jolts you awake, your brain is working exactly as it should. The weird physics of your dreams aren't a malfunction. They're a feature. Your sleeping brain protecting your waking body, even when your mind is miles away.
If you want the full neuroscience of REM sleep, vestibular misfires, and how to leverage lucid dreams for actual skill learning, grab the free Neuro Quirks Field guide in the description. It has a whole section on recognizing dream signs.
the slow motion movement, the gravity anomalies, the physics breaks, so you can start catching yourself mid-dream and taking control. Subscribe, and we'll decode another one of your brain's silent experiments next week.